Cannizzaro's reaction. This is today's lesson. Cannizzaro's reaction is a kind of chemical reaction in organic chemistry named after the Italian chemist Stanislao Cannizzaro. This reaction proceeds through oxidation and reduction simultaneously. That is why this reaction sometimes called redox reaction. This reaction is known as disproportionation reaction as well. Cannizzaro's reaction involves aldehydes with no alpha hydrogen atom. In this lesson we are going to learn aldehydes without alpha hydrogen, reactions and definition of Cannizzaro's reaction, mechanism of Cannizzaro's reaction, crossed Cannizzaro's reaction, and finally mechanism of crossed Cannizzaro's reaction. So let's go to the detail. Cannizzaro's reaction involves aldehydes with no alpha hydrogen atom. Let's see aldehydes without alpha hydrogen atom. First of all, CH3, CH2, CHO. This is propanol. In this compound, carbon atoms are numbered in two ways, 1, 2, 3. And when carbon atoms are numbered in the chain by Greek letters, then the carbon which is linked up with functional group carbon, that is mentioned by alpha, then this is beta. So this carbon is alpha carbon, and at the alpha carbon these two hydrogen atoms are called alpha hydrogen atoms. So in this compound there are two alpha hydrogen atoms. So this is the compound with alpha hydrogen atoms. Now let's see aldehydes without alpha hydrogen atom. This is 2,2-dimethyl propanol, 1, 2, 3. When carbon atoms are mentioned by Greek letters, then this is alpha, this is beta. At alpha carbon, no hydrogen atoms. So in this compound, no alpha hydrogen. So this is aldehyde without alpha hydrogen. Let's see another example, formaldehyde. In this compound, this is functional group carbon, and with this carbon no other carbon atoms. So in this compound no alpha carbon, so no alpha hydrogen. Another compound, benzaldehyde. This is alpha carbon, but at the alpha carbon no alpha hydrogen. So the aldehydes having no alpha hydrogen. Let's move on to the next point. Now the point is reactions and definition of Cannizzaro's reaction. Let's write Cannizzaro's reaction. Aldehyde with no alpha hydrogen atom. Formaldehyde having no alpha hydrogen atom. Another formaldehyde, that is two molecules of aldehyde having no alpha hydrogen atom, is treated with concentrated or 50% alkali, sodium hydroxide or potassium hydroxide, and the reaction is carried out at the temperature 20 to 30 degrees Celsius. Then one molecule of aldehyde is oxidized to carboxylic acid and another molecule of aldehyde is reduced to alcohol. That is, here this aldehyde group turns into carboxyl group. Here this aldehyde group turns into this group. That is, through oxidation aldehyde group turns into carboxyl acid group, and through reduction aldehyde group turns into alcoholic group. That is, one molecule is oxidized to carboxylic acid and another molecule is reduced to alcohol in presence of concentrated alkali like sodium hydroxide or potassium hydroxide. Let's see another reaction. Benzaldehyde. Another molecule of benzaldehyde treated with concentrated alkali at the temperature 20 to 30 degrees Celsius. One molecule of aldehyde converts to acid, carboxylic acid, and another aldehyde group of another molecule turns into alcoholic group like this. Then this compound turns into benzoic acid and this one turns into benzyl alcohol. Here this acid reacts with this alkali, so it converts to sodium salt of carboxylic acid. This acid converts to sodium salt of carboxylic acid, reacting with this alkali. Let's see another reaction. CH3, 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 CHO. Aldehyde with no alpha hydrogen atom. Another molecule CH3, 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 CHO. Reaction proceeds through oxidation and reduction between two molecules each, treated with concentrated sodium hydroxide or potassium hydroxide, and it is carried out at 20 to 30 degrees Celsius temperature. Then this group turns into carboxyl group CH3, CH3, CH3 that ultimately turns into sodium salt of carboxylic acid, and this group turns into alcoholic group like this one CH3, 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 CH2OH. That is, this is sodium 2,2-dimethyl propanoate and this is 2,2-dimethyl propanol 1, 2, 3. So this is 2,2-dimethyl propanol and this is sodium 2,2-dimethyl propanoate. These are the reactions of aldehydes with no alpha hydrogen atom. Now let's see definition of Cannizzaro's reaction. Aldehydes which do not contain alpha hydrogen like formaldehyde, benzaldehyde, 2,2-dimethyl propanol undergo simultaneously oxidation and reduction in presence of concentrated alkali like sodium hydroxide or potassium hydroxide. Then one molecule is oxidized to sodium salt of carboxylic acid and another molecule is reduced to alcohol. This type of disproportion reaction is known as Cannizzaro's reaction, which is named after the Italian chemist Stanislao Cannizzaro. Let's move on to the next point. Now the point is mechanism of Cannizzaro's reaction. Let's see step by step. Step 1, concentrated alkali like sodium hydroxide produces sodium ion and hydroxide ion. This hydroxide ion in the second step reacts with aldehyde. Oxygen is electronegative atom than carbon. Oxygen's electronegativity is 3.5, carbon 2.5. So oxygen gets partially negatively charged, carbon gets partially positively charged. So this negative ion combines with this carbon. Then we get hydrogen, carbon, hydrogen. This carbon oxygen double bond turns into carbon oxygen single bond with this charge. Here OH. Now this ion reacts with another aldehyde. It becomes negatively charged, it becomes positively charged. When this ion interacts with this molecule, then this lone pair of electrons forms pi bond. At that time, this hydrogen is released as hydride ion. Release of negative ion, which is known as reduction. And this hydride ion bonds to this carbon, which is called oxidation. Now the species formed is hydrogen, this carbon oxygen double bond, here OH plus, this one is CH3O minus, this minus, because this carbon oxygen double bond turns into carbon oxygen single bond with this negative charge. As this is acid, it donates this proton, hydrogen as proton, and this proton bonds to this oxygen. Then we get formate ion and methyl alcohol. This formate ion combines with this sodium, which is produced in the first step. Then this formate ion turns into sodium salt of formic acid. So here aldehyde with no alpha hydrogen atom, one molecule is oxidized to sodium salt of carboxylic acid and another molecule is reduced to alcohol, which occurs through transfer of hydride ion. Simultaneously oxidation and reduction happen. That is why this reaction is called redox reaction at times and disproportionation reaction as well. Let's move on to the next point. Now the point is crossed Cannizzaro's reaction. When two kinds of aldehydes are taken, then the reaction occurred is known as crossed Cannizzaro's reaction. Let's see the reaction. For example, formaldehyde and another kind of aldehyde that is benzaldehyde. This reaction is treated at concentrated alkali and it is carried out at around 25 degrees Celsius temperature. Then formaldehyde turns into sodium salt of formic acid through oxidation. This is compulsory. And benzaldehyde turns into benzyl alcohol through reduction. In this case, this formaldehyde turns into sodium salt of formic acid through oxidation. This is a must. It will be cleared when we will see mechanism of crossed Cannizzaro reaction. So it's a kind of reaction of different kinds of aldehydes. That is why this reaction is known as crossed Cannizzaro reaction. Now let's see mechanism of crossed Cannizzaro reaction. And we will understand why formaldehyde turns into sodium salt of formic acid through oxidation and benzaldehyde turns into alcohol through reduction. Let's see mechanism. Mechanism of crossed Cannizzaro reaction. Let's see. First step is concentrated alkali produces sodium ion and hydroxide ion. Step 2. This hydroxide ion attacks aldehyde molecules. Here, this is one aldehyde molecule and another one is this, that is formaldehyde molecule. So here this hydroxide ion attacks either this carbon or this carbon. This bond is polarized, it gets negatively charged, carbon gets positively charged. This carbon oxygen bond gets polarized, oxygen gets negatively charged, carbon gets positively charged. So this hydroxide ion will attack this carbon or this carbon. Here we see this carbon is linked up with two hydrogen atoms, but this carbon is linked up with one hydrogen atom and another one is a big group which is phenyl group. Because of the presence of big group, this hydroxide ion cannot attack this carbon easily. That is known as steric hindrance. Because of the steric hindrance, this hydroxide ion cannot attack this carbon. So this hydroxide ion attacks this carbon and let's get what is obtained. Hydrogen, carbon, hydrogen. This is oxygen with negative charge. This is hydroxide ion. Hydroxide ion combines with this carbon, then we get this compound. Now this lone pair forms pi bond. This hydrogen gets freed as hydride ion, which is reduction. Now this hydride ion bonds to this carbon, benzaldehyde carbon, that is this benzaldehyde carbon, which is positively charged. So this hydride ion bonds to this carbon, which is oxidation. Now we get, from this ion we get formic acid and benzaldehyde turns into benzyl alcohol. This formic acid combines with this sodium, which is produced at the step 1 to form sodium salt of formic acid, sodium formate. So because of the presence of big group hydroxide ion cannot attack this benzaldehyde carbonyl carbon. That is why this cannot be acid, but hydroxide ion attacks this carbon, formaldehyde carbonyl carbon. That is why this formaldehyde turns into acid easily, because here no big group, but here big group present. This is called steric effect or steric hindrance. So due to steric hindrance from the formaldehyde and benzaldehyde, formaldehyde must turn into formic acid through oxidation, and as a result benzaldehyde turns into benzyl alcohol through reduction. Another point is, here we see that this ion releases hydride ion, but if hydroxide ion attacked benzaldehyde carbonyl carbon, then benzaldehyde would be like this, minus here OH, here benzene ring. If hydroxide ion attacked this benzaldehyde carbonyl carbon, then it would form. Here phenyl group is a kind of electron withdrawing group. That is why from this ion, releasing of hydride ion would be very tough. So this is another reason hydroxide ion attacks the formaldehyde and formaldehyde turns into formic acid. Because of the steric effect and because of the electron withdrawing tendency of phenyl group, benzaldehyde cannot turn into benzoic acid. This is all about Cannizzaro's reaction and crossed Cannizzaro's reaction. No more today. Thank you very much.